Hey, hi everyone. Very good evening. Hi Anil. Hi Hush. Good evening. All right. So is my voice is loud and clear to you? Is my voice is loud and clear? All right, fine. Great. So welcome back to EDL session with ExcelR. So we are on the third week, the last week, but we'll be having one more day. 25th will be our last day. So it has to be, suppose it should be ended by 22. But since we have the first day, since that has been taken 2 times, I think it will be extended till next Monday, till 25th. Okay. So let's get into today's topic. But again, before that, what are the things we have discussed in the last session? What are the topics we have covered in the last session? Let's do a recap and then we can get into it. What are the topics we have covered in the last session? So great. Anil. So summary. Okay, great task. Reach friends, 3 different data sets, collect data, set images of image, collect what image contains one person, Rajinikanth one. Okay, okay, great. Srisha, right, TensorFlow Keras architecture. And we worked on that MNIST data set, and I think you should be having a good understanding about how we are going to construct our neural network step by step. That's what we've been through in the last session. So today we are going to get into all right, Arun. All right, great. So today we are going to get into CNN architecture. Only the theory part we are going to touch it today. In case if time permits, if you're able to understand script also, let's we can get into in today's session. Okay, let's see how exactly this would go. So, but before that, let me do a recap what we have covered till now. So we discussed, we just started understanding from brief history of AI, that is industrial revolution we discussed. And then we got to understand that we are in this digital transformation industry 4.0. We are into this particular century, and where we are trying to make everything connected with IoT devices, web applications, mobile applications. We are into that. And then we understood about the life cycle of a data scientist. So after that, we discussed about different IDs, and we got an understanding why we are choosing Jupyter Notebook for learning. We learned it. And then we got into basics of Python programming part, where we spent 2 days of time, and I think we all worked on call, and also some tasks I've given for you to get practiced into this Python programming part. And then we got into Python data structures, where we discussed about list, sets, tuple, and dictionaries. And again, task we worked on it. And after discussing Python data structures, then we got into Python libraries, where we discussed about pandas library, which is used for data analysis. We discussed, and then we got into statistics, data visualization, because we got on data visualization, where we again discussed about matplotlib, seaborn, plotly, how to choose between them, on what basis we have to choose the right chart between, by understanding discrete and continuous data types. So we learned it over there. And then we got into this statistics session. We spent 2 days over there. So statistics is all about making a statement about present. For that, we looked onto the measures of central tendency, measures of dispersion, skewness, kurtosis, normal distribution we have understood. And then random variable and probabilities we learned it. So whenever randomness is the root of all probabilities, we have spent a good amount of time over there. After that, we got into machine learning, where we spent 1 day of time in understanding how exactly we picked up one machine learning algorithm, that is linear regression, and we worked on that newspaper data set that is based on the daily circulations, how exactly the Sunday circulations it will be. And then we got into artificial intelligence session. So the basic difference between machine learning and deep learning is all about machine learning's major limitation is structured data. Deep learning deals with images and video related data. And then deep learning is basically inspired by how human brain got constructed, that is neurons concept and everything. So each and every neuron is getting connected to another neuron inside our human brain. So we looked at how biological neuron will look like, and then the same thing, the researchers, they made it artificial way, and they named it as artificial neural network. So within that, we are having 6 building blocks, that is learning rate, batches, iterations, optimizers, different loss functions, different activation functions. So we learned different activation functions, different optimizers, different loss functions. We learned it. So at what time we have to use which activation function, and which loss function, which optimizers, we learned it. And also, I think I've asked you to work on by trying different optimizers, gradient descent, NAG, and switching into NAG, and ADA-grad and everything. And also we worked on this MNIST data set in the last Friday. So up to this, clear, everyone? Till the session, what we have discussed. Jyoti, yes. Harsh. Srisha, clear. All right then. Great. So let's get into today's topic. So today we are going to discuss about CNN theory. If time permits, we can get into CNN scripting also. Okay. All right. So now whenever we are reading, whenever we are discovering new topic, the very first question is the thing, but why CNN, right? Why convolutional? I would say CNN, it means that convolutional neural networks. Okay. So now why we need to learn this particular CNN, I'm getting a question. Okay. Now this basically when we are discussing about CNN, so let me give you this complete picture. That is, it comes under a computer vision problem statement. All right, we call it as computer vision problem statement. So this computer vision, which is nothing but an eye. As a human beings, we are having eyes, and we are collecting the data. Right, we are seeing the things. In a similar way, if a machine need to have an eye, that's what we call it as computer. This is a very vast. There's a vast subject here, but we are understanding only few. Computer vision. This computer vision is divided into 2 types. All right. One is image classification. Image classification. And the other one is image, or we can say object detection. Even here also we can say object classification. All right. Image classification The major thing is classification detection. Now, what is this classification and detection? Seems a very common thing, is nothing but here in this classification problem statement, it is going to classify in one particular image, whether this person is Harish, is whether it is Harsh, or whether maybe it is going to say whether it is Harsh or whether it is maybe, let's say, maybe Jyoti. All right. So this completely, even if there are two objects it is present, it is not going to create two objects. No, it is going to say whether it is Harsh or Jyoti or Supriya, or only one answer it is going to do. That's what classification is all about. Image detection is nothing but in your image, you can have n number of objects. All right, let's say this is Harsh. Or let's say this is Jyoti, maybe some other person. All right. So here, my machine is here. What exactly it will do? It is going to create one rectangular box on top of the face, and just going to say this is Harsh. Here it is going to create a box, and it is going to say it is Jyoti. This one is Anil. In this way, it is going to create a rectangular box on top of the face, and it is going to say in one image, if I'm able to detect only one object, we call it as image classification. In one image or any video, if I'm able to detect multiple objects, we call it as object detection. So what we are going to discuss nothing but the CNN concept basically applies in CNN algorithm concept for CNN basically is for object classification. So CNN is used in this classification problem. Within object detection, we are going to use something called as YOLO concept. YOLO, and we are having RCNN. In this way, we are having a lot of things. All right. And even within this YOLO, CNN concept is available, but particularly we will be speaking about YOLO. YOLO 5. YOLO is nothing but you look only once. That's what the concept is. But again, we can discuss about this later. But the major point here is nothing but for image classification, that's what we are going to get into it, and where exactly we need to study about CNN architecture. Right, has regional convolutional neural networks, RCNN. We are having RCNN, faster RCNN, even RCNN, fastest RCNN. This way we are having a lot of things. Right, Jyoti, you're right, correct. Fine. So is this point clear? Two divisions. Fine. All right. Now, the next question which I'm getting in my mind is why CNN when we are having ANN? Why CNN when we are having ANN in our hand? ANN is nothing but what? Artificial neural network. Basically, ANN is, instead of saying ANN, we can say feed forward neural network. ANN is nothing but whatever the network we are constructing, it is artificially we are constructing. So, but we can say feed forward neural network over feed forward neural network. Feed forward neural network is nothing but I'm having input layer, hidden layer, output layer. All right, what we have learned in the last session, we are having a 28 by 28 image. All right, and we are flattening it and sending it. But what are the disadvantages of flattening? The image is like this, sorry, the file is like this. Now directly you're taking all the pixels, right? All the pixels. So here you're taking, and also when you're taking this pixel and presenting it here, this value, the dimension is getting missed. Firstly, the dimension, the spatial dimension is getting missed. Secondly, you are including all the pixel values, or each and every pixel you're just trying to take it. But is it really required to make classification? I'm getting a question. So now take a look at this particular image and see what exactly it is. So what this image is all about, once take a look at it and tell me. 1 minute. So this image is what? What is this image? Everyone not saying it is dog, right? Yes, obviously the answer is right. Now, but this is the complete image. Just once observe this, how exactly you made a classification. Okay, so how exactly you made a classification? So once we are able to see the eyes and the nose and maybe the ears, This is more than sufficient for me to make a classification between whether it is a dog or whether it is a cat. That's how, as humans, we are trained with. In the similar way, why do I need to see this? Let's say this image dimension is about, let's consider it as maybe 1000 by 1000 pixels. All right. So the length and width is 1000 by 1000. Where exactly 1000 pixels I'm having here, and towards the length and towards the width. So I need to take all these particular pixels here, this pixel, this pixel, this pixel, every pixel I have to create it like this. So, but it is not actually required because this feature is something that's required for me to make a classification between whether it is a dog or a cat, isn't it? Yes or no? Yes. What's the depth of an image? Depth of an image is nothing but channels. We say it is an RGB. It's a red color, green color channels. Again, we can speak about it later, about depth and the channels and everything. So here, this is the question which I've raised here. All right. So now if you take a look at it, so here, only this feature is something sufficient for me to make a classification between whether it is dog or a cat. Right. Now I want to find a way to eliminate this kind of background informations and to extract this particular crucial information. All right. Only this particular feature. To extract crucial features from my image, we need CNN. All right. So before I give to this particular feed forward neural network, I try to take this image. Give this image into CNN architecture. This is my CNN architecture. And then so after giving this particular CNN architecture, my image size will be reduced. Now, then I flatten it, because I would be having only this particular important features. Even if it is going this particular way, that's not a problem because I'm having only important features. Then I flatten it, give it to this particular input layer. Flatten is nothing but input layer, and then hidden layers, and then output layer. 2 neurons I can have it. Maybe I can use softmax activation function. This is for dog, and this is for cat. So before I give it to feed for a neural network, I extract the crucial information by using CNN architectures. I reduce the dimension of a particular image, and I give to this particular feed for neural network. Is this point clear? Why CNN? Jyoti, got it. Fine. Now let's understand, great Amol. So now let's understand how exactly the CNN architecture will look like. Okay, let me share this particular screen. Let me share another screen to you all. So, let me share my Blackboard. Let's try to understand from by taking an input image, we are going to give to the CNN architecture. So step by step, there are 3 levels what we're going to study. So let's go step by step here. So let it get open, right? All right. Now, this is the architecture of CNN network. All right. Where if you look onto it, we are taking an input image, okay, and we are multiplying with the conva matrix, and the resultant or the output, we call it as a feature map. Then we give it to a ReLU activation function. The output of ReLU activation function, we call it as a rectified feature map. Then it is getting multiplied with max pooling layer, and then it is getting the output, we call it as a resample feature map, and then we flatten it, give it to the feed forward neural network for prediction. So this is something in architecture. Now let's go step by step and understand how exactly this would work. Okay, see this. I'm taking an input image, and multiplied. This is not multiplied by one. This is multiplied by one. So this determines whether it is a black and white images or a grayscale image. So here, if I'm just writing multiplied by one, or we can say by one, it means that only one depth, or I can say only one channel I'm having in my data. Okay, so first let's take this black and white images. Now, as we know already, what is this 8 by 8? 8 pixels I'm having to the left hand side, 8 pixels I'm having to the right hand side. But think practically, can we have a good clarity image in 8 by 8 pixels? Is it really existing in today's world? 8 by 8 pixel value? What do you say? No, 8 by 8 is not at all present. Even it will be very small, which is not at all visible itself. But we are just taking this 8 by 8 for the purpose of understanding. There's not much clarity. Even we worked by 28 by 28. Even that is also not good clarity, right? So we now today we are going with 4K images, 80 images. That's what today world is moving ahead. But let's understand this 8 by 8 with respect to it. Just a mathematical calculation. I'm trying to explain it here. So here 8 by 8 is nothing but totally I'm having 64 pixels. 8 by 8 is nothing. 64 pixels is available in this particular image. Now, from this particular image, I'm multiplying a 3 by 3 conva matrix. This is where math comes into the picture. Those whoever from commerce background or math who love math, just see this. This is a conva matrix of size 3 by 3. Okay. This 3 by 3 can be of any size, 3 by 3, 5 by 5, 4 by 4. It is something, it's up to us to pick it up. But what exactly is happening? This 3 by 3 matrix, I'm going to construct it. And this matrix is going to get applied on top of my image. So 3 by 3. So what would be the multiplication of, let's say here, the first 3 by 3 and this 3 by 3 value? It's nothing but a random numbers. I need some numbers from a uniform distribution or a normal distribution. I will be saying that from which distribution I need some random numbers. I will be telling my network no. So from this random numbers what will get initialized, just we have to give the what size we want. So 3 by 3, everything is random. So this 3 by 3 matrix will get multiplied on top of this particular 3 by 3. It's nothing, first 3 by 3. The resultant output will be of how many values will be getting it up? How many values will we get as a 3 by 3 multiplied with 3 by 3? This 3 by 3, when it is getting multiplied with 3 by 3 matrix here, I will get how many values? Is it 9 values will getting it up? So -1 multiplied by this value plus 0 multiplied by this value plus 1 multiplied by this value plus and 0 multiplied by this value. Finally, you will be getting only one value, right? I'm not asking about what's the matrix size, the final value, how many values? Only one, right? -1 multiplied by -1, -1 multiplied by 0 multiplied by this value, plus 1 multiplied by this value. Then the second row, then the second row is an addition, multiplication and addition. Finally, if you're adding it, you'll be getting only one value. So my question is, when you take this 3 by 3 matrix and up the first 3 by 3, you'll be getting it up. Now move from left to right. So how many times it can move from left to right and top to bottom? Just observe this. I will be showing in another visualization as well. How many times I can take this 3 by 3 matrix and move from left to right at one steps and top to bottom by one step. How many times I can move? Let me go a bit slowly. Wonderful, Jyoti. Great. Okay, Harsh. Just think, everyone. You can post it whether it is right or wrong. I'm not judging anybody, but I want you to think and post your answers on the chat box. How many times I can take this 3 by 3 I move from left to right and top to bottom. Okay, Kaya. All right, Harsh. Now Harsh increased by 2 units. Okay. See this? Let me explain this particular part. So what? Two. This is 3, 4, 5, 6, 7, and 8. So if you count it, it's an 8 by 8 pixel. Okay, let's try to have an image here. Maybe all right. Maybe a cat or something. All right. Now it's an 8 by 8 pixel. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So it's an 8 by 8 pixel. This is the dimension of my image. Now I'm going to multiply this matrix. I'm going to multiply this matrix with 3 by 3 conval. 3 by 3 conval. All right. Now, when I'm taking this and I'm multiplying it here, how many times I can move? That's the question. So one time, then move from left to right. 2, 3 by 3. This 3, finally you'll be getting one value. So let me take this. So by multiplying this, you'll be getting one value. So that's my first box. And then first box. And then this second one value, second box. Then this box, 3. And then fourth box. And then till here, fifth box. And then till here, 6 times. So if it is moving from left to right, 6, the same thing, right? Top to bottom, 1, 2, 3, 4, 5, 6. Sorry. If it is still here, 1, 2, 3, 4, 5, 6. Means the ending point I'm just giving it. So the resultant feature map will be of how many pixel values? It will be of how many pixel values? 38 pixel values. So what would be the dimension? Great amount, correct. So what would be the dimension? It is 6 by 6. You understood this point once again for me? Everyone, Dr. Adela, perfect. Great. Wonderful, correct. So this movement from left to right and top to bottom, technically we call it a strides. All right. Technically we call it a strides movement. So you can give strides is equal to 1 or 2. It's up to us. Here I just went with strides is equal to 1. Where exactly I'm moving from left to right, one step at once. Now, why we have to do is nothing. But see this is a rectangular box. So when you're taking this particular rectangular box and applying it here, and to pick some other color, maybe when you're taking it, let's say here it's a 3 by 3. Okay, 3 by 3. Now you're multiplying, numbers are getting multiplied, and you're going to pick up some important pixel values, right? And finally you'll be getting one value, and again this multiplication one value, and again you'll be getting multiplying an important value. So the resultant number, it will be something good compared to all the other pixel values. Yes or no? What do you say? So I'm just capturing the important pixel values, by multiplying with the conva matrix. Feature extraction is happening because I'm just going with the shape of 3 by 3 or 5 by 5. When I'm multiplying this matrix, we call it as a conva matrix, or we can say conva matrix nothing but a weighted matrix. Weighted matrix. We know weights is nothing but a random numbers. Is this point clear? All right. Now let's take a look at some images. Show this. So I just wanted to look onto conva layer multiplying with an input image. See this? Yep, maybe you can take a look at it. This is an input image of any dimension: 3 by 3, 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 3 by 3. Okay. So now the resultant, if you look onto it, the resultant, I'm getting some important pixel values over here. All right. And here, if you look onto it, here it is just giving a 0. Why? Because, all right, so look onto the movements, just observe the movements, that should be fine. Left to right movement we call it strides, and top to down movement again we call it strides. So kernel, this conva matrix is also called as kernel, or kernel. We can call it as a kernel, or we can call it as a conva matrix, or we can call it as a weight matrix. So these are all the other terms that we can just address this particular conva matrix. It's nothing but a weight matrix. You can just look onto the multiplication. Finally, you will be getting one number, which I'm just substituting here. G23. Okay, see this? How exactly it's getting multiplied? I'm getting the value and everything. Fine. So this image size is nothing but 3 by 3, sorry, 3 and 6 by 6. But when I'm multiplying with this conva matrix, here I'm just getting 4 by 4. So the original dimension of my image is getting reduced. So here there is a problem. What is the problem is nothing but what if your image is having, in your image, in case if your image is present here, all right, and this is in this way. So the last dimension here, if you're going with 3 by 3, only one multiplication will happen, right? The last two horizontal lines, or sorry, the vertical lines here, the more multiplication is not happening, because if you look on the in between where the image is not at all present, here I'm doing 3 by 3 again. See, look onto this particular column's chance. Okay, this third column chance, 1 3, first one, second one, 3 chance this one particular column is getting. But when I'm just moving towards the right hand side, in case if my image is present over there, once I reach to the corner, I'm doing only one multiplication where more feature extraction is not happening. So in case if the object, if it is present at the right corners or any other corners, I want to do the same number of multiplication even at the corners. So that is nothing but the feature map size. This conva matrix 3 by 3 or whatever it is need to get applied to the whole image size, let it be at the corners or whatever. So what I'm doing in order to achieve that, I'm just giving zeros across my matrix, so that now if it is 0, now I can just move one step, right? 3 by 3. Now again, to do this, again I can just do 0 across this particular matrix. Now because of this, what will happen is nothing but my conva will get multiplied with all input images, and even at the corners also it is going to take, even the feature map size will be also of the same size of my input image size. So this process of adding zeros across my matrix input image, we call it as padding. Why padding? Because the resultant feature map should be of the same size of my input image. We go with padding. So now see this with padding, what I'm trying to achieve. If we can take a look at one the GIF file again. See this here. Let me give maybe what is that padding in CNN. Here, let's take a read on it. Padding is a term relevant to convolutional neural network, as it is refers to the amount of pixels added to an image when it is being processed by the kernel of a CNN. For example, okay, for example, everything here, let's take a read on it. So see this. So let me take some other image. Let me take padding GIF. Let me take it. Fine, you can just take a look at this one. This should be fine. See this? Now, if you look onto this, what is the input image size here? This is the input image size. What is input image size? 1, 2, 3, 4, 5. And even left hand side, 5 by 5. So now what I've done, I just said I want padding. Because of this, what is the resultant feature map size? After adding padding, we are not including the padding size also, because at just the zeros we are creating manually. Now, what is the resultant feature map size? Again, 5 by 5. Now, after multiplication, I'm getting a good numbers with respect to this particular matrix. So the process of adding zeros, look onto it. Here I'm having an equal chance. Even I can just go padding 2 zeros also I can make it. But if I'm not giving this particular padding, this will never happen. Got my point over here? To make input image size same as my output feature map size, we are adding zeros across my input image so that we can achieve this particular part. Right, Amo, correct. Same size of input image. So to achieve that, we got this particular thing. All right, so padding is done. Now let's do one small calculation with respect to this, with padding and without padding. So this padding and everything is controlled by something called as, again, we are having mathematical equation behind the scene. So here we are at this particular stage, feature map. So output of this particular feature map size is given by this mathematical equation where n plus 2p minus k divided by s plus 1. What is this? N is nothing but input image size. All right, and p is nothing but padding. K is nothing but kernel size or canvas size, and S is nothing but strides. All right, now let's go do some calculation without padding. Okay, now we are not going to give padding. So here N is nothing but what? Input image size is 8. So 8 plus 2P. Are we going to give padding? No, without padding, 0. Minus K is nothing but kernel size, that is your canvas size. Canvas size is 3 by 3. So minus 3. Divided by strides is nothing but 1. That is nothing but how many movements you are making from left to right and everything. So if you're doing it, 8 minus 3 is 5. 5 plus 1 is 6. So the resultant feature map will be of size 6 by 6. And with padding, so just you have to substitute. N is nothing but 8 plus 2p. Yes, I want padding, so I'm just giving 1. Minus kernel is nothing but 3. Divided by strides nothing but 1 plus 1. It's nothing but what? 8 plus 10 is 10. Minus 3 is 7. Plus 1 is 8. So it will be 8 by 8. So with padding, my input image size will be same as equal to output of feature map. Without padding, the feature map size will get reduced. So padding controls, padding and also strides. Strides is also very important. But the major thing, because if I'm going with 2 moments, again, it will get affected. We can say padding and strides both controls the output of my feature map. Got my point, everyone? Up to this clear? Okay. All right. Now let's move ahead. Now the output of this particular feature map will have both positive and negative values, right? See this? The output of this feature map will have minus 26 minus, because the image pixel values, what is the image pixel value range? What is the image pixel value range? Is it 1 to 255 ratio? What is the pixel value range of an image? Pixel value range, Amol. Range. Right, now you're right. It is 0 to 255. So image pixel, does it has any negative values? Image pixels, does it contain any negative values? Image pixels, no. Image pixel, it is not right, Jyoti. So image pixel, right, Kyle. So now image is not going to have any negative values, but weights, this weights can take negative values because the normal distribution nothing but 68% should be from -1 standard deviation, one standard deviation, two standard deviation, three standard deviation, which means that -1 to +1, -2 to +2, -3 to +3. So that's what the values will be. From that distribution, I'll take it and I'll just present some numbers. Even there are a lot of other distributions as well. I'm just keeping the base as a normal distribution. So the weights can be negative. So now the resultant one, I wanted to eliminate this negative pixels because image doesn't operate with respect to negative things. So for that reason, even if you wanted to eliminate the negative, we can do that. But to eliminate or to make a negative value 0, which activation function we have to choose? Which activation function will reject negative values completely? Is it sigmoid? Sigmoid is a classification, right? It will take from 0 to 1. Can we keep it as in the hidden layers or for the purpose of learning? One second. For better learning purpose, we try to give other activation functions, right? ReLU activation function, rectified linear unit. If you look onto the graph, what we have learned, it is just nothing but for all the negative values, it is going to make it 0. And all the positive pixel values, it is going to give the same value. So for that reason, to make all the negative pixels 0, we are selecting ReLU. It is nothing but always do we have to select ReLU? It is nothing like that. We can go with the tanh, we can go with the rectified linear, leaky ReLU, we can go with exponential linear unit. It's up to us. But here, according to the research, what they're saying, ReLU is doing a pretty good job compared to all the other activation functions. You can try it out. So, right, Amol, we can do that. So here I've mentioned ReLU activation function. So let's go with that ReLU activation function. So now I'm just giving ReLU activation function. Because of that, here this value -26, it will be 0. This will be 0. This will be 0. This will be 0. Most of the values it will be 0. Yes or no? Only the positive pixel values I'll be getting into all the negative pixel values, it will be 0. Yes or no? Yes. So what I'm doing, again on top of this, I'm going to apply another layer called as max pooling layer. Now, what exactly this max pooling layer will do? Why max pooling layer is nothing but for feature reduction, we can say, or dimensionality reduction. Dimensionality reduction is nothing but now your output of feature map is of the same image size, that is 6 by 6, output will be 6 by 6. That's what we have studied. Now the image size is same thing. I'm not reducing my image size, but it need to get reduced. So for that reason, we are getting into something called as max pooling layer. What exactly this will do, max pooling layer? Let's try to look onto it. Max pooling layer in CNN. Let me look onto it. All right, see this. My input is nothing but your output feature map. Okay. Now what is doing? Max pooling layer here. If you see, this matrix nothing but it's a size of 2 by 2. We are selecting a size of 2 by 2, and we are moving. How many strides we are moving? How many strides we are moving here? Right. What is the strides value? How many steps we are moving from left to right? That's 2. Is it 3, Jyoti? See this? We are starting from here. 1, 2. So the strides is nothing but 2. Now we are selecting the strides is equal to 2, and matrix size is also equal to 2. After selecting this up, out of the 7387, the name itself says max pooling. Pick up only the maximum pixel value. So now what is the maximum pixel value? 8. I take it here. That's it. Only 8 I take it. Now I move left to right. 5216, which is the maximum value 6. I take it here. Now 49008, which is the maximum value 9. I remove. I'm not considered about this 4 and 8. 3945. Now only the important pixel is 9. So now I take it again 9. So by doing this particular process, we are again going to eliminate some unimportant pixel values. If it is 0, again it is going to get eliminated because feature reduction is happening. So for that reason, if you look onto this particular architecture again, it's a size of 6 by 6. Now I'm going with the strides of 2 and the matrix size is 3 by 3. Now 6 by 6 it will get reduced to which size? If I'm going with strides is equal to 2, 6 by 6 will be reduced to exactly half, right? It will be reduced to, it will be reduced to 2 by 2, 3 by 3, right? One, check it out. Yes, it will be 3 by, that's what the size which I mentioned. Now if you multiply it 3 by 3, how many pixels I got it? 9. Earlier we got 64 pixel. Now we got 9 pixel, which is very important. With respect to feature corner matrix, you extracted important features. And with respect to max pooling, you reduce the dimension. And after that, you're flattening it, giving it to the feedforward network for the prediction. So this architecture we call it as convolutional network architecture. Feature extraction for convolutional convo matrix, and feature reduction we are using max pooling layer. Got my point, everyone? All right. Here we are using padding is equal to 0. Right, Amal, correct. I think you already know the concepts behind this. Great. So now let's get into the next part, that is, see this, there is one particular image here. One minute. All right, let's take, there is one image. All right, it's not getting done. Fine. Let's take a look at this. So there is one particular image here. Where exactly this? This got changed. All right, so this image, let me keep it here. Fine. So this image is of size, let's imagine it's of size 1000 by 1000 by 3. Okay, so this is the image size, what we are able to see. 1000 by 1000 by 3. So this 3 y I've given is nothing but this is a colored image. So lengthwise 1000 and the height, actually it is 4000 by 6000 pixels internal having, but again for the purpose of calculations and everything, I just made it 1000 by 1000. Now earlier case, that is a level 1, we discussed about a colored, grayscale image. Now we are going to do a calculation for one colored image, we are going to do it. All right, so this is one image which we got. Now this image size is of 1000 by 1000 by 3. Now what is the number of pixel here? By 3 is nothing but 3 layers internally I have. If you look onto this particular part, image colors, see this, an image RGB channels. See this. Whatever the image that we are seeing today, it's a combination of 3 colors. Look onto it. If you're able to see, it's a combination of red color, green color, and blue color. Combination of 3 colors we are having it. Each and every red color, the color pixel value ranges from 0 to 255. Green color 0 to 255, blue color 0 to 255. If you're working with some photo image editing applications, you will remove some green color light. You will increase the saturation. You will give a vintage, something like that. You photo image editing you do. So, but the point here is nothing. But I'm not going to get into that particular topics. But here we are going to understand an image compressed of 3 channels: red color, green color, and blue color. Together, we are able to see one colored image. Now, because of this particular reason, right, Jyot, because of this particular reason, since we are having 3 channels, I just mentioned 1000 by 1000 by 3. This 3 determines it is a colored channel, right? Now, to extract some important features from this particular image, I'm multiplying with one convo matrix of size 5 by 5. Now let me give you one small clue. Again, this is a very small size. If image is of 1000 by 1000 pixels, okay, on what basis I have to choose the convo filter size is nothing, but let's imagine this 1000 by 1000. So now you're choosing 5 by 5. All right, let's say, or 3 by 3 you're choosing. 3 by 3 is nothing but 3 by 3. Yes or no? 3 by 3 pixels. Is it a right choice of choosing 3 by 3 pixel for 1000 by 1000 images? Is it a good choice of choosing of or going with 3 by 3 convo matrix size if the image size is 1000 by 1000? That is the question. No. So on what basis we are going to pick up the convo matrix size? 5 by even 5 by 5 itself, it's a very small dot. So even if it's a 5 by 5, why you are unnecessarily increasing the computation time and everything? Because at the end of the day here, more space it's there. So maybe we can go with 15 by 15, maybe 15 by 15, right? So your convo matrix size. So this is one important question. On what basis you are going to choose your convo matrix size? It completely depends on the input image size. If the input image size, if it is 1000 by 1000, I go with the higher convo matrix size of 15 by 15 or 19 by 19, like that. If the image size, if it is something like 256 by 256 or 128 by 128, I may go with 5 by 5 or 3 by 3. So it completely depends on my input image size. I choose my convo matrix size. Got my point? All right. Now let us go back to this blackboard. Let's understand this. So again, for the purpose of maths calculations, this is 5 by 5. I choose it for 1000 by 1000, which is not a good thing to choose it. Now again, let's understand one math we are trying to get it. So I'm going to with the size of 5 by 5. This convo is going to get multiplied with my input. This is my input image. I chose a strides of 1, moving from 1 to left, and I'm saying padding is equal to yes. So now if I'm saying padding is equal to yes, my feature map will be of the same size, 1000 by 1000. But here I'll be having all negative pixel values because convo matrix is nothing positive and negative values I'll be getting. It's just a weights, random weights. Now the output of feature map will have both positive and negative values. When it is getting multiplied with the or getting into this ReLU activation function, most of the values will be 0. That is the negative values will be 0. So that is rectified feature map. I'm just giving it feature map 1, rectified feature map 1. So when I'm just applying this max pooling layer on top of this rectified feature map 1 with the strides of 2, and I'm going with the size of 2 by 2, then the desample, then the output matrix size, it will be of what size? From 1000 by 1000, strides equal to 2. It will be of what size? Again, Hamul, just wait for a while. Here the depth is 1. We haven't gone into that. Here, what is the depth of, sorry, what would be the resultant feature map size? If I'm going with strides 2 from 1000 by 1000, it will be exactly half, right? 500 by 500, perfect. So the resultant feature map, after applying this max pooling layer, desample the feature map 1, it will be of size 5 by 5. Now again, what I'm doing, and again, I still wanted to extract some important features. So what I'm doing, I'm just multiplying one convo matrix of size 5 by 5. And then again, why? Because already I've done convo and max pooling. Why again another convo? Let's imagine within this particular part, the first convo is responsible to extract some edges. Let's say your eye edges and ear edges. That's what it is trying to calculate. But is it doing the same job, exactly doing the same job internally? We don't know. Or what exactly it is going to extract it. We can't see it in our human eyes. But what we can understand, okay, the first convo, it is going to extract the edges. Now I got in this particular desampled feature map 1, I got imported edges with respect to 500 by 500 pixels. Now only with respect to edges can I make a classification? No. Still I wanted to extract more important features. Now again, what I'm doing, now again, I'm just multiplying in another convo matrix of size 5 by 5. Yes, I'm saying padding is equal to yes, strides is equal to 1. I'm multiplying this particular convo on top of my resampled feature map. Again, this because padding is equal to yes. The resultant feature map will be of the same size, 500 by 500. Here, feature dimension is not happening. Again, to eliminate some negative pixel values or to make it 0, we are multiplying with ReLU, rectified feature map 2. Now I'm again applying max pooling layer of size 2 by 2, strides is equal to 2 by 2. So what would be the resultant or desampled feature map size after max pooling layer here? If I'm going with a size of 2, that is strides. Wonderful. 250 by 250. Great. See this? 250 by 250. Now again, what I'm doing, okay, now let's say from this important edges, I formed the shapes. Let's say eye shapes, I formed it, and ear shapes, I formed it, and hair shapes, I formed it. Now again, I wanted to extract even more features. Again, what I'm doing, again, I'm just applying one more activation function. One more convolve matrix of size 5 by 5. So this is from the important shape. Let's assume this is going to this convolve feature is going to extract more complete object. Let's say complete. It is going to combine all the shapes and it is going to form one complete object. It's of size 5 by 5. And the resultant feature map, the size will never get reduced 250 by 250. Redo activation function to make all the other pixel values like 0. And then the resultant feature map. And then max pooling again size equal to 2 by 2. Now, what would be the size of desampled feature map 3? What would be the size of desampled feature map 3? 125 by 125. Why padding is 1 this time? Padding is nothing but padding equal to 1 is nothing but I want to make padding. 1 is nothing but I'm saying yes. 0 for no, 1 for yes. That's it. So can we increase strides in max pooling? Yes, we can do that. We can do that, but accordingly your feature size, the desampled feature size, it will get affected. Anyway, today I'm not going to get into the scripting. Let's focus only on the theory part, and then maybe we can wind up the session. I'm not loading more theory today. Because if you get into scripting again, it will take some time, maybe another 1.5 hours to get into it. So let's be strong in this theory part today. Let's try to give most of the time here, and then we can get into script tomorrow. Not a problem. All right. So max pooling of size 22. Here, if you see, now the desample feature map of size 125, 125. Now initially you got 1000 by 1000 by 3. Now that is maybe 330 lakh something pixel you got it. Now 125 by 125. Now if you're flattening it, 15,625 neurons, you will flatten it, send it to the feedforward neural network. So it's nothing but CNN architecture is nothing but convo max pooling, convo max pooling, convo max pooling. So in this way, you're just constructing it sequentially. And after that, finally, you're deciding I wanted to flatten it and send it to the feedforward network for the prediction. That will happen. In this way, you can have n number of convo max pooling layer. You can have convo max pooling layer, convo max pooling layer. So in this way, architecture design is something up to us. Okay, we can design in any ways, but this is the very base to. But the point is convo max pooling. This max pooling can be there are a lot of pooling layers we have. Average pooling, a lot of pooling layers we have, but again, I'm not getting into that details. But the point is convo max pooling. In this way, we can just construct it sequentially to come up with a very good architecture. Got my point, everyone? Up to this. Dr. Leela. Fine. Already somewhat. Maybe you can go through this recording if it is not clear. I know this is a bit difficult to take it. If it is, if you're feeling it difficult, again go through the recording slowly. It should be fine. All right. Fine. Now the third level. That's what we are going to. I think Amol is asking for a long time. That is nothing but convo features, or we say it is a filters. Now the same concept in the level to what we have learned. It's 1000 by 1000 by 3 pixels, or it's a colored image. Now what I'm doing here in this particular part, we learned this one convo that is 5 by 5 is going to extract edges. Now what if I have in this way? What if I have maybe many convo matrix? Another 5 by 5, another 5 by 5, another 5 by 5. In this way, at the first level itself, if I'm having maybe eight with this part we call it a depth. This depth, or we can say it is a features, or we say it's a filters. So what if I have eight such filters or eight such convo features at the first level itself? I can extract more edges, right? What do you say? So here I'll be having one edge. Here I'll be having one edge. Here I'll be having one edge. In this way, the depth of the network will get increased. So in order to have extract even more edges at the first layer, or we can see even more features at the first layer, I'm just going with something called as one concept called as convo features. Okay, so because of this, so according to the research and everything, what they're saying, they start with 8, 6, 16, 32, 64. In this way, they're just trying to go. But if you see now, the depth of the convo filters, it's getting increased. 5 by 5 multiplied by 8. 8 is nothing but we can say it's a depth of the network, or we can say 8 such convo filters I'm having at the level 1, or we can say features or 8 such layers of convo at the level 1. Now, when it is getting multiplied here, again I will be having see this 5 by 5 is getting multiplied. 8 such filters 8 such convo filters I'm having it. The resultant feature map also will be having 8 such 8 such layers. That is the depth. When I'm multiplying it again 1000 by 1000 by 8. Again, if I'm just going with the max pooling layer of size 2 and size strides equal to 2, only the image dimension, this depth is not going to get changed because it's 8 depth we have it. Only this 1000 by 1000 will get reduced to 500 by 500 by multiplied by 8. Now again, this is going to extract edges, important edges. Now the second column, when I'm multiplying it, I'm just increasing the number of depth. From 8 I started because from the edges I have to form as many shapes as possible. So again, I'm just going with 16 such filters, or we can say I'm increasing the depth of the network. Again, it's up to us to design our own network. So here I designed with increasing the number of convo filters. So again, 16. So now what would happen? 500 by 500, when it's multiplying by 5 by 5 multiplied by 16, 16 such depth I will be having it. So 500 by 500 multiplied by 16 depth I'm having it. Again, ReLU 500 by 500, 16. One more max pooling layer. So the image dimension is going to get reduced by 250 by 250 multiplied by 6. Now I'm having important shapes. Now I want to form a complete object. So now again a convo matrix. Now I'm again increasing the depth to 32. So from the matrix size is 5 by 5. So now it is 250 by 250 multiplied by 32 such depth. And again 250 by 250 by 32. And then from the image size need to be reduced. So I'm going with 125 by 125. And then I flatten it, send it to the feedforward network. Now my question here is nothing but which one is more good in feature extracting? I need to have more features or only one features? More convo features or only one feature is sufficient? What do you say? More feature is better. More convo features. So that's the reason we always try to create great trail. So that's all. 3 levels is completed. That's all the theory of convolutional neural network. All right. So the point here is nothing but if you're having as many layers as possible, it is going to extract more features from this particular network, and feature extraction will be happen. All right. So the point here is nothing but convo max pooling, convo max pooling, and convo max pooling. That's it. And I'm going to construct my network, and it is going to give me this it is going to process it, and it is going to give me this particular output. That's it. So before sending it to your feed forward network, you're going to give to the CNN network. We are constructing it manually, and this network will take all your inputs, and it is going to process it, and then it is going to send it to the feed forward network for the prediction. And all this forward propagation, backward propagation, everything is going to happen. Finally, we'll be getting this particular output. That's it. Got my point, everyone? Right. Wonderful. So this is all about CNN. I think we are having some more time. Let's do one thing. Let's try to complete the first half of scripting today. Maybe we can get into the second half tomorrow. 1 minute. So right. Yeah. So let's take maybe how many minutes break you wanted? The first of till model architecture building we can do. Maybe other parts so we can take it tomorrow. 5, 6, 7 minutes. How many minutes you want to take a break? 5 minutes, is that fine? All right, great. Fine, then let's go for 5 minutes break. Maybe I think we are having some more time. Let's try to make use of this time. 5 minutes timer to start it. Let's go for break now. Maybe we can resume the session at 8:15. All right, let's go for break. Hi everyone, it's all back from break. Only Jyoti is back. Others. Oh, wonderful. So let's open up a new Jupyter notebook. We learned about this theory. Let's get into the script part of it today itself, since we are having some time. So let me open this. So we are, where are we? This one. Here, let me create a new folder, and let me, okay, already deep learning got created. So let me not create it new. Deep learning. So here, let me create a new Python file. Let me rename it as CNN for multi-class classification. CNN for multi-class classification. All right. So the step number one is import necessary libraries. So import necessary libraries. So we know mostly we are going to work with TensorFlow. So what you can do, maybe you can import TensorFlow. That is sufficient. TF, let me give it. Even we can check out the TensorFlow dot version also. We have already installed this in the last session. Okay, it's 2.7.0. Now the recent one is 2.8.0, but let's work with 2.7.0 now. Now, the second point is nothing but since we are having, I think you should be having a data in your local directory. Okay, if you have not created it, this session is won't it will you only will be able to see how exactly this would work. But in case if you're having your own data set, you can get a hands-on training. All right, so that's a part of this. The second step is nothing but import data. All right. Now there are a lot of ways how you can import your data into your working environment. So now one of the ways that even I use nothing but image using something called as data augmentation, or we can say image augmentation technique. Import data using image augmentation technique. Now, what is this image augmentation? Let's take a read on it. Image augmentation techniques. Now, what is this? What is or data augmentation technique? So see this data augmentation technique generate different versions of real data set artificially to increase its size. Computer vision models use data augmentation strategies to handle with data scarcity and insufficient data diversity. The problem is nothing but let's say you're having only 5 images or 10 images, you're not having more images. Now, what will happen in case if you're going with image augmentation technique, it is going to pick up, let's say, one image. And within this, it will take one image and it is going, this is original image, it is going to augment it. Augment is nothing but it will tilt it, it will just zoom a bit, it will give some shear ratio, see this, it will just go for some vertical flip, horizontal flip. Internally, it will generate a lot of duplicate images from the original image so that it is going to expand the size of the image size. And this will not happen explicitly. This is an internal mechanism. See this random rotation, flip, zoom, and random shift. So these are the processes that can happen within data augmentation techniques. So this image augmentation is available within my Keras itself. So what I'll do, let me go to this. So from Keras, I think we discussed about it. Let me give this particular tab button. You're having applications. Let me click on this applications. Sorry, not applications, pre-processing, because you're going to pre-process data. Let me scroll down. So here you are having a lot of things. Slowly you can take time and read it. Pre-processing. What you wanted to pre-process, you wanted to pre-process your image. Let me click on it, image. So here from this particular package, I'm going to import something called this. Let me give a tab button. I got this data, image data generator. Okay, this is what it is going to do. Let me click on it. Shift enter. I got it. Now image data generator. Within this, what are the things we have? See this feature center, zoom ratio. In this way, we are having a lot of things within this. Now what I'll do, let me pick up one day something. Maybe let me take zoom range and shear range. It is basically 0 point copy. Still, I am not taking any, providing any path, but I'm just giving zoom range equal to 0.02. This one is nothing but 0.5 maybe. Vertical flip, horizontal flip is false. Let me copy. It's a default functions, right? So it's something if you want to do, we can tweak it. True, vertical flip true. And that's it. So generate batches of tensor images data with the real-time data augmentation. Data will be looped in batches. So now you can just take a read on this particular part, what exactly to be given, how I'm just giving true or false. So it's something I'm just reading it. That's what the point is. You can take a read on data. So this one I have to do for this particular image. And also one more part. This will just do one pre-processing is nothing but even we can just rescale it. For example, we can, the image will be of 0 to 255 range. I can do the rescaling as well. So here, where is the, yeah, rescale is available. Let me copy. Let me paste it here. Let me divide this particular values by. So what you can do is nothing but with whatever the values coming in, 1 dot divided by 255. This nothing but it is nothing but with whatever the values I'm just getting into my network, it will just convert it into a float and it is going to get multiplied within this particular process. That's how it is just going to. Now rescaling is used for just rescaling a particular image. See this, how exactly to be given. Again, you can take a read on it. Rescale, what exactly this will do. Scroll down, find out, see this, rescaling factor. Defaults to none. If none or 0, no rescaling is applied. Otherwise, we multiply the data by the value provided. So 1 multiplied by whatever the value the image is coming in. So after multiplying all the transformations, we do that. So here I'm just giving 1 point or 1 divided by 255 multiplied with the other value. So what exactly this will happen? Even you can give 1 dot also. So we give 1 by 255 multiplied with the pixel values is 55, whatever it is, multiplied to 55. So 55 divided by 255 is nothing but the values will be between 0 to 1. You got my point, everyone? You all got my point? The way how we have done yesterday, just a normalization part. All right. So this part I have to do, and this one need to be done for my training images. So what I'll do, this one, let me just store it into this process. Let me store it into train data. Okay, still I have not provided the path. But for the test data, whatever we are having, what we need to do, we don't need to create vertical images and flip and everything. So what I'll do, let me create image data generator, because it also need to be rescaled. So what I'll do, rescale is equal to 1 divided by 2.5. 1 point is meant for some float values. By default, it is going to create float values, but I'm just making it explicitly. That's it. Test underscore data. Okay, only rescaling I have to do for the test data. Right, now this part is done. Now the third step, what is the next step is nothing, but now I have to provide the path. So once this is getting stored, yes, Amol, only normalization for, because only for the training data, I have to do this vertical flip, horizontal flip and everything. Why do I need to go do it for test data, which is, I'm not even going to train my particular model. So now what I do, let me go for this respect to train data. Now here, if you give dot, you would be seeing a lot of things. Okay, a lot of functions you can see. Now here you're having something called as flow from directory. This will help you to take your data from your uh, where exactly your local folders are available. You can just give it. Now it's a function. So let me open and close it here. Directory. All right, directory, and target size is 250 by 256 by 256. Let me copy. Let me paste it here. So what is the directory? Directory is equal to what need to be given? Directory string. It should be in a string path to the target directory. It should be of even PNG image also taking in PNG, JPG, PMP, TIFF files also it was taking it. But earlier when I tried, it was not allowing TIFF files in everything. Okay. So now see this within single quotes. Now let me go back to where exactly my folders are. It's in my D and it's in my, where is that? Let's see. Let me share this. So my folder is available here. So so this where, yeah, so this where I created. If you look onto this Suresh, I'm having some images. Already, if you look onto it, it's 7.67 MB. And let me look onto the properties. So if you see details, it's 6000 by cross 4000 pixel values. So it's a very high picture dimension. But even whatever the image is collected, it's very poor. Why? Because see this, some letters are there and a lot of unwanted spaces are available. And this is better. This is how we have to collect it. And again, there are some unwanted spaces. Only background image. If I'm providing only this image, this should be fine. So maybe Suresh, I'm giving it. Superman, let me click on it. So this many images I'm going to give it. Again, see this lot of this kind of other object. It's a balloon. So this shouldn't be there. Only image and that particular person, it should be available. All right. Maybe Ian, so this another images. So in this way, I'm having maybe Mary. In this way, I'm having multiple images, which is available in my particular data. Now what I'm doing, I'll just copy this particular path, Control C. All right, let me come back here. This path, I'm copying it. Let me paste it here. All right. And again, that's it. Only the path you have to give it. And since you're taking the data from 1 minute. So since you're taking the data from a different directory, it will to avoid throwing in error, just read the file from another direction. So I'm reading the file from another directory, and the target size, very, very important point. Now, what is this target size? Nothing but let it be whatever the image size is. Now, the image size is 6000 by 4000. Just multiply it, how many pixels value you'll be getting it. So in order to process that pixel values here to go with the Canvas X and everything, our CPU is not sufficient. CPU power is not at all sufficient. So what we do, let it be whatever the image size is. Now, by providing this particular path, I'll take this image and I'll reduce the dimension to 256 by 256. Even 256 by 256, length is 256 pixels, height is 256 pixels. Even that will also take so much time. So what I'm doing, let me reduce it to 128 by 125. Just we are understanding the architecture. We just need to know how the flow will work. So I'm reducing it to 120 by 128 by 128. So now what are the other things? Class mode is categorical. Okay, because of more outputs. Batch size is 32. All right, fine. So this part, let me just store it into, this is my, let me, yes. So let me store it. This is my training data path. All right. So let me store it here. Training data path. Now, similarly, provide your test data path also. Test data paths here, you are having a test data. Let me copy. Dot again, you're having flow from directory. Again, where exactly it is available? The test data, or do we have it? This is a parent. Image test files. Yes, here I have it. So present in another location. Suresh test file, see this. Only one file I got it for test. Superman, I have some images for testing, which is not available here. Yeah, similar images for other testing. But this data I have not provided for training purpose. Let me copy this path. Come back here. Let me single quotes. Let me paste it. Fine. Again, target size, because the default target size is 256 by 256, but since I've changed it, let me make sure here also change. And this is nothing but what? Test data path. Now if you execute it, see this, it is saying found 110 images belonging to 5 classes and found 53 images belonging to 5 classes. So 53 images for testing, 110 images for training. Up to this, clear everyone? Data collection, how we are reading the data from our local directory. All right, perfect. So now we just given the path and we collected the data. Now internally, how exactly this will happen is nothing but internally it is a dictionary mapping. As I think I mentioned this part last time. So 5 classes. Now, if you see training data path, it says it is 5 classes. It's all about creating labels, right? Because when we are constructing these neurons, so here, how many neurons we will create it at the output layer? How many neurons? For my case, how many neurons I will create it in my output layer? How many neurons I'll create it? Wonderful, Harsh. In my case, I will create 5 neurons. All right, output layer. I'll create, since the output classes is 5, I'll create 5 neurons. All right, and this neuron label is nothing but 0. This neuron index is 1. This neuron index is 2. This is 3. This is 4. It is nothing but it is a kind of index numbers. All right, its index number start with 0. Now here it is saying 5 classes. Now what this neuron belongs to which part I want to understand. So for that, what I'm doing, training data path dot tab button. If you're saying class indices, there is something called as class indices. Look onto it. So it is an alphabetical order basically. Eon, it mapped it for 0. All right. So this neuron belongs to Eon. All right. This neuron belongs to Eon. And the second one, this neuron belongs to John. Third one, this neuron belongs to Mary. This neuron belongs to Superman. And this neuron belongs to Suresh. Based on the alphabetical order, it will get triggered. Now here I'm having a very big network. Based on this, only one neuron will get triggered. I'll supply my image, it will get into the network, and finally one neuron, one day it will get triggered. Let's say this particular neuron's pixel probability, if it is higher, only this will be triggered, and this is going to say this one is male. Okay, so it's a dictionary mapping it has done, because behind the scene, as I told you already, it's nothing but it is working with numbers. That's the concept here. Right. Now we imported our particular data. Let's go and build our CNN network. All right. So let's build it. Let me build my architecture. Third step. Build the, or we can say model building. Model building. All right. So in this particular step itself, data collection, data understanding, data preparation, everything is done. Now the next step is model building. So as I said, model building is a 2-step approach. So first is nothing but 3.1, build your architecture. And then the second step is, what is the next step? After building the architecture, what is the next step? That is compile architecture. Great, Srisha. Second step is compile your architecture. All right, compile your architecture. Now let's build the model. We can say with CN architecture. All right. Now, what are all the things that we require? It's nothing but again from all the layers is present inside Keras. So from Keras, let me import this particular first sequential. I have to do it sequential. After that, some layers from Keras dot layers import. I need this particular convo. See, I'm just giving it convo 2D layer. I want it. Comma max pooling layer, max pooling 2D and have, comma. Then I use flatten layer, comma. Then I use dense layer. So these are all the layers that we are going to use it one by one. Govind, it's already provided, Govind. Attendance link. Maybe Amar, can you post the attendance link one more time? So these are all this particular functions that we needed. Right now, it has been imported. Now the next step is nothing but let's construct it. Let's build our architecture. So architecture, let me, okay, convert 2D. First layer itself is nothing but what? I have to create this particular pipeline. So sequential. Govind, you can take it. Sequential. So this, I think we already learned it. Let me store it into model. All right, now it is done. Once it is done, model dot, we can add layers one by one. Add, which layer firstly we have to add it? First itself a convo layer. So let me give convo 2D. All right, 2D. Within this, it's a function within this. See this. This layer creates a convolutional kernel that is convolved with the layer input to produce a tensor outputs. Right. Now, when using this layer as the first layer in a model, provide the keyword argument input underscore shape, copy, because it's the first layer, input underscore shape. Example is equal to, in this way we have to give it. For 128, by 128 RGB images. See this, comma 3 is for your colored images, right? Is equal to 128 by 128 by 3. So make sure this size, even let me give it, sorry, 128 by 128, comma 3, here we have to give it. Because the colored image, right? So let me execute it again. 3 we have to give it because it's a colored image. So input image, input shape we have given, comma. Next one is, all right, let me look on our filters. Filters nothing but the depth of the network, the dimensionality of the output space, number of output filters in the convo. So let me try to use maybe 8 such filters, or it is an integer. Kernel size. Kernel says nothing but the filters you selected. I want 8 filters, but what is the size of your kernel? For 128 by 128 image size, what kernel size we can choose? What do you say? Image size is 128 by 120. What size we can pick it up? Can you suggest any size to me? 5 by 5, even I feel 5 by 5 is pretty high, but we can go with that. Maybe 3 by 3 or 5 by 5, anything is fine. Again, how do I need to give it? We can give like an integer or a tuple or a list of 2 integers. So what I'll do, let me go with the tuple maybe. So maybe 3 by 3, let me go with this kernel size, comma. Strides is nothing but again, it is an integer or a tuple of 2 integers. Why of tuple? Because left to right movement and top to right down movement. Here, let me give it like integer. Let's say strides is equal to 1. That's what I wanted. And padding, see this. Padding is equal to 1 of valid or same need to be selected. Valid means no padding. Same means results in padding with zeros evenly to the left or the right and or up or the bottom of the input. When padding is equal to same and strides is equal to 1, the output has the same size of the input. This is very important. That's what even we discussed. Let me give a comma. Padding is equal to, let me give something like valid. All right, because if I'm giving valid, it means that there is no padding at all. Then what exactly it means? Activation. Activation is nothing but input layer and then convo matrix is getting multiplied. After that, which one need to be triggered? Which activation function? We learned is nothing but reload. Let me give reload. And anything else? See this kernel initializer. Kernel initializer is nothing but glow out uniform. Glow out uniform is nothing but it's a weight matrix. Okay, it's from the uniform distribution. It's actually a normal distribution is taking it. Bias initializer. Bias is again a random number. From which distribution you have to take it? Again from a normal distribution. In this way, we are having a lot of things. Take a slow read on it. You should be able to get it. Now what I'm doing, this is my first layer. Let me add it. Okay. Now here it is done. Now here, let me close this. Let me look on to one layer has been added. Model dot summary. Only one layer I added. See this? From 128 by 128, the image size is getting reduced. Why it is getting reduced? Why it is getting reduced? Because there is no padding. In case if I say same, now see this. Now let me execute this line. Look onto it, 128 by 128. Okay, so either you can keep it valid or same, but here I kept it valid because that's what the shape I wanted. So now convo is done. After convo, what is the next layer? After convo, what is the next layer? Max pooling. Wonderful. So what I'll do, model dot add. Okay, this one add I already written. I want to add this max pooling layer. So let me type max, tab button, I got it. Max pooling 2D. Here if you see down samples, okay, down samples input along its spatial dimension, height versus width. Now what are the things that need to be given? Let me scroll down. I want arguments to have, yeah, pool size. Pool size nothing but integer or tuple of 2 integers. Over to given. So 2 by 2 will take the maximum value over the 2 by 2 pooling window size. If only one integer is present, specify the same window integer will be used for both the dimensions. It's nothing but an integer or whatever you can just give it. So pool size, let me give it to pool size equal to, I'll just want to go with 2 by 2 and also strides integer or tuple of integer strides value specifies how far the pooling window moves from moves for each pooling step. If none, it will be default to pool size. What is the pool size? It is 2, so it will go with 2 by 2. So, but explicitly, let me give it, it's nothing but 2. Take 2 moments to the left to the right and top to bottom. Now, after this, okay, now if I'm just giving max pooling size, what would be the output size after max pooling? What would be the output shape after max pooling according to this architecture? It will be 64 by 64. See this? This will never get changed because that is the depth of the network that is not going to get affected. Only this input image is going to get reduced. All right. Now, in case if I wanted to have or add one more convo max pooling, just copy this, copy and paste it here. The second layer. But second time, do we have to give this input shape? Second time, do we have to give this input shape? Do we need to give this input shape? What do you say, everyone? No, it's not required. So let me remove this. Maybe I can increase the kernel size to 16 and rest all things, let it be the same thing. Now, after this again, what would be the, if I'm just giving it a convo and max pooling, what would be the size, the resultant feature map size or output shape after the second max pooling layer? Wonderful, Amol. Jyoti, one think on it. Yes, it is going to be 32 by 32, ordered 16 such layers. Now what I can do, I just wanted to flatten it. Model dot add. Let me flatten this. Flatten network. That's it. Just only you can just flatten it. So what would be the flatten network series after flatten? So 32 multiplied by 32 multiplied 16. I just got this particular neurons. So this one, let me just give it to my feedforward network dot add. Feedforward network is nothing but dense layer. Dense layer, just I need to go with this. Units, arguments, units, let me copy. Let me paste it here. Units equal to, let's say I want maybe 300 neurons. And what activation function? I just need to go with maybe ReLU activation function. ReLU. Anything else other than this, everything is default. Let me use this. In case if you wanted to use one more activation function, one more hidden layer, let me copy, paste it. And the last one, I wanted to keep it as a dense layer. So here, how many units I have to pick it up? 5, because it's a 5-class classification. In case if you're going for 3-class classification, if you have collected 3 folders, just mention it as 3. And which activation function I have to select here at the output layer? Which activation function? Is it ReLU, Niharika? Output function. Is it sigmoid? I think you all missed it. Yes, Harsh, great. So I mentioned this point again, and it's obvious that you will forget it, but that's okay, note it down. For binary classification, in case if you're giving only one neuron here, you can use sigmoid. Okay, you can use sigmoid. And if you're using softmax, just try to go with two activation for two or more, you can just, if in case if you're creating two neurons or more than two neurons, go with softmax activation function. Why? I've already explained that in the activation function. In case if you don't know, if you're not clear with why I'm just giving this, go back to the activation function recordings. Once watch it again, you should be good with it. So for multi-class classification, we are going with softmax, and Wi-Fi because of 5-class classification I'm doing it. If you're going with 3-class, again 3, the same activation function you do it. All right. So this is my network model construction. Up to this, clear everyone? All right. So what is the next step again? Compile model dot. Compile we have. Compile. Just choose this 3 metrics. That's it. Optimizer, loss, and metrics. That's it. Copy to give it. I want to go with Adam. Loss is nothing but it's a sparse categorical entropy loss because he labels his integers basically. So, but I'm not sure how to give it because it is case sensitive. So let me get into keras.io. Let me copy directly from there. Keras AP reference, the losses, sparse probabilistic losses, sparse categorical entropy loss. Yes, so let me copy. Matrix is nothing but it is an accuracy metric. So let me use accuracy. All right. Model compilation is done. So post model compilation, it's nothing but model training. Step number 3.2. That is, sorry, 4th step. Model training. Okay. So in model training, what we do, model dot. Okay. Fit is used for training. So here what we can do, fit you can do X and Y, you can provide X and Y. And let me just copy and paste what are the necessary things. And the batch size, maybe by default, it's going to be 32. Epochs. And validation data, where is that? Validation, yes, validation data. Anything else? Fine. All right. Now, let's say epochs, I think we already know. Let's say I want to go for 10 iterations. And batch size by default, it is going to be 32. Whatever the image size, if it is 110, 110 divided by 32, it is going to pick up that many images, it is going to process. Now, how do I need to provide X and output? Because in the last case, we had X train and Y train. That's how we provided. So in this case, we are having only folders. How to do this? So input data, X can be, it could be a NumPy array, or we can say a TensorFlow list of tensors, or a dictionary mapping inputs name to the corresponding tensors. Okay, look on it. If the model has named inputs, so a dictionary mapping inputs to the input names to the corresponding tensors. So what you can do, where it is given, this X is nothing but X is given in training path generator. Let me copy this. This path I'm going to give it here. So if that's the case, I don't need Y. Okay, because X itself it is having a dictionary mapped to name it with respect to the output. Already it is having it. So I don't need Y over here. Now, how exactly validation data it need to be become? Validation data, let me come back. Data on which to evaluate. So it could be, I think we already read it. So it could be tuple X comma Y, or NumPy arrays, or we can say a tuple of this one, validation inputs. Or again, if you're reading it, it is nothing but it could be again your dictionary itself. All right, it can be a dictionary. So your validation data, again, what you can do, you can provide your test data path. All right. Now I'm not executing this line. Try this execution in your local machine, and it will take minimum 3 to 4 hours to get executed. But let it run in your local machine. In case if you're having, if it is not at all getting processed, or if your machine is getting stuck in between, or if it is getting automatic shutdown, just try to remove these two layers. All right, just hide it. Just hide it because this demands high processing power. Conva max pooling, flattening. This demands high processing power. In case if you don't have it, just for practicing purpose, just hide these two layers and I can execute it. Even to execute this line itself, it will take 2 to 3 hours. In case if you're adding these two networks, these two lines, it will again take 5 hours or 6 hours. But I just wanted to give a try today. Come back tomorrow. From here, we will train our network. And also tomorrow we will learn in order to overcome this for faster processing, what we can rely on, we can also work with collab as well. So that is the reason, if you remember on day one, as I said, to deal with images and videos, we need GPUs. With CPUs, the processing time, it will be very higher. So how to work with Google Colab with respect to the same project, tomorrow we will be having a discussion about it. But try to execute this and just check how much time it is taking. You'll be getting an asterisk symbol. It will take a lot of time. But in case if you're doing it, try to store it into something like model underscore performance, because we can have a, what is that, some performance result also, like training loss and something we can take a look at it. So just store it here and just observe how much time it is taking in your local machine and come back tomorrow. All right. Is it clear, everyone, up to this? Is it possible to generate plot of? Yes, that's the reason we are storing into model performance. In case if you're not storing it here, you won't be getting that history option. So that's the reason I just asked you to store. In case if you miss this, if you only use model.fit, if it is taking 4 to 5 hours time, then again you have to store it into a variable to plot it. So to avoid that, again, we can better store it with respect to one variable. In that way, we can do that. All right. Fine then. So that's it for today, everyone. So, sir, I just want to know if I'm completing 40 hours correctly. Amar, I'm not sure how you're completing 40 hours. Not getting a question about. Maybe you can write a mail regarding all your attendance sheet and everything. I'm not keeping a track on it. There's another team, Amar and ExcelR team. They are looking into all your and attendance sheets and everything. You can write a mail to the team and get it done. But it can be plotted with which variable? The same variable what we are storing. In the last session, we just model.fit, we have given it to one variable. And then with respect to that variable, let's say model performance. Here we are storing it to model performance. Model performance dot history object, or we can say history function. We can get all this accuracy score and everything. We can go for the plotting. Just once look onto the previous script, you will be getting. Great, Amar. Fine. So is the session, today's session, understandable? Is it interesting? How do you feel, everyone? Or do you feel we are going a little bit fast? Or is the space good? All it's lost. Great then. So in case if you wanted to change the page or anything, just put it on the feedback form, whatever you're getting on a regular basis, we can get to know about it. All right. Great, everyone. So today we discussed about CNN architecture theory and also script wise. We looked on to it. I will just share all this materials in your for today's section. We can take all the access. Okay, it's lifetime access. You can just take it out. Take care, everyone. See you all tomorrow at the same time, 7 p.m. Good night. Yes, Harsh, take care. Take it. Bye, Jyoti.